We here at Intel do quite a bit of research in understanding how customers use their systems, design test methods that would mimic those environments, and eventually do a rigorous understanding of if the products that we design are meeting those specifications or not. And that's what it makes it unique and different from other people who do that.
We have a job where we're trying to figure out, where does it break? It may be common for some people to test a very small number. We're still looking for, okay, let's say it passes all the reasonable expectations, let's get a little unreasonable. Where does it break, and how can we make it better next time? So you're looking at different environments that the system could go into.
We're basically responsible for providing data to the quality and reliability engineers to guarantee that the products that are going out to the market meet industry standards. On the environmental side, you would see temperature cycling equipment that will basically run for thousands of hours, trying to stress from extreme cold to extreme hot temperatures.
So we can't wait around 7, 10, 20 years for a device to fail to figure out where the failure mechanism is. So we'll apply a much more extreme environment.
The tools have capabilities to go anywhere from 2,000 to 10,000 Gs, depending on the specific profile that we're trying to emulate. From 50 Gs to 100 Gs is the type of stress that we would typically subject a unit to. You're handling your phone and oops, I dropped it. Or you're traveling with your computer or your compute stick on a rough road. Those are the kind of usage models that we try to emulate in our lab.
Test them at the silicon level, you test them at the package level, you test them at the form factor level. Very smart individuals and groups together, they can develop a test to get data much quicker at Intel than they can at other sites.
The main goal and the main value that we add is to ensure that our products will survive in whatever environment that we target, and not just perform, but exceed their performance envelope.
Something else that we definitely do differently than others is after we do some of our torture tests, is we're actually tearing things apart to see, is there something that's microscopically broken that will make it so that it's a little bit unstable in the customer's hands.
We use a wide range of technologies, ranging from X-rays to infrared scanners to cross-sectioning to microscopy. The details to which we can go actually can be as low as nanometer scale. We have fancy tools that can do good chemical fingerprinting of what materials exist on a given surface. It's called surface characterization. We also have electron microscopes which can do elemental analysis, which can tell you what elements are existing in the given area. People who come in and contribute range from electrical engineering, computer science, materials, mechanical, physical, chemical analysis. For the mainstream deep dive analysis, we have people who have PhDs, masters. When we develop these products, we tailor them to unique customer demands, to the extreme complex situations which they run into and use it.
You want to make sure that you're not interfering with anything. So you wouldn't be very happy if your computer system made it so that you didn't get your television signal. We're making sure that we meet all those guidelines, that we're not emitting radiation that we shouldn't be.
Intel provides global support to all of our production level Intel branded products. So we have 196 countries that we cover, over 23 languages that we cover, and we have an escalation process that takes you directly to our team, and we have working relationships with the engineers that design the product that you have questions about. Our goal is to make sure that our customers are successful with Intel products.
We expect our systems to keep working for a really long time. We want it to keep working after you don't care anymore. We're not going to walk away at the end of the day if something goes wrong and say, oh no, we're not going to support that. We're going to keep supporting it because that's what Intel does.